Hello everyone, welcome to the DOS Tech new video. We have already talked about what is OSI model and 7 layers in the OSI model in details. Now we'll talk about what is this TCP IP model which we used in recent days. So the OSI model has 7 layers, but TCP IP model has a different layer, what we are using to use in computer network and for data process as well. TCP IP was designed and developed by the Department of Defense (DoD) in the 1960s, and it is based on standard protocols. It stands for Transmission Control Protocol, Internet Protocol. The TCP IP model is a concise version of the OSI model. It contains 4 layers, unlike the 7 layers in the OSI model. The number of layers is sometimes referred to as 5 or 4. Here in this video, we'll study 5 layers. The physical layer and the data link layer are referred to as one single layer, as the physical layer or network interface layer is the 4-layer reference. What does TCP IP do? The main work of TCP IP is to transfer the data of a computer from one device to another. The main condition of this process is to make data reliable and accurate so that the receiver will receive the same information which is sent by the sender, to ensure that each message reaches its final destination accurately. The TCP IP model divides its data into packets and combines them at the other end, which helps in maintaining the accuracy of the data while transferring from one end to another end. What is the difference between TCP and IP? TCP and IP are different protocols of computer networks. The basic difference between TCP, Transmission Control Protocol, and IP, Internet Protocol, is in the transmission of the data. In simple words, IP finds destination of the mail and TCP has the work to send and receive the email. UDP is another protocol which doesn't require IP to communicate with another computer. IP is required by only TCP. This is the basic difference between TCP and IP. How does the TCP IP model work? Whenever we want to send something over the internet using the TCP IP model, the TCP IP model divides the data into packets at the sender's end, and the same packets have to recombine at the receiver's end to form the same data. And this thing happens to maintain the accuracy of data. TCP IP model divides the data into a 4-layer procedure, where the data first go into this layer in one order and again in reverse order to get organized in the same way at the receiver's end. Layers of TCP IP model: application layer, transport layer, TCP, UDP, network or internet layer, IP, data link layer, MAC, physical layer. The picture comparison of the TCP IP and OSI model is as it is. First, physical layer. It is a group of applications requiring network communication. This layer is responsible for generating the data and requesting connections. It acts on behalf of the sender, and the network access layer on the behalf of the receiver. During this video, we will be talking on the behalf of the receiver. Data link layer. The packet's network protocol type, in this case TCP or IP, is identified by the data link layer. Error prevention and framing are also provided by the data link layer. Point-to-point protocol, PPP, framing and Ethernet IEEE 802.2 Framing are two examples of data link layer protocols. 3. Internet layer. This layer parallels the function of OSI network layer. It defines the protocols which are responsible for the logical transmission of data over the entire network. The main protocols residing at this layer are as follows. IP. IP stands for Internet Protocol, and it is responsible for delivering packets from the source host to the destination host by looking at the IP address in the packet headers. IP has two versions, IP version 4, IP version 6. IP version 4 is one that most websites are using currently, but IP version 6 is growing as the number of IPv4 addresses is limited in number when compared to the number of users. ICMP. ICMP stands for Internet Control Message Protocol. It is encapsulated within IP datagrams and is responsible for providing hosts with information about network problems. ARP. ARP stands for Address Resolution Protocol. Its job is to find the hardware address of a host from a known IP address. ARP has several types: reverse ARP, proxy ARP, gratuitous ARP, and inverse ARP. The internet layer is a layer in the Internet Protocol IP suite, which is the set of protocols that define the internet. The internet layer is responsible for routing packets of data from one device to another across a network. It does this by assigning each device a unique IP address, which is used to identify the device and determine the route the packets which should take to reach it. For example, imagine that you're using a computer to send an email to a friend. When you click send, the email is broken down into smaller packets of the data, which are then sent to the internet layer for routing. The internet layer assigns an IP address to each packet and uses routing tables to determine the best route for the packet to take to reach its destination. The packet is then forwarded to the next hop on its route until it reaches its destination. When all of the packets have been delivered, your friend's computer can reassemble them into the original email message. In this example, the network layer plays a crucial role in delivering the email from your computer to your friend's computer. It uses IP addresses and routing tables to determine the best route for the packets to take, and it ensures that the packets are delivered to the correct destination. Without the internet layer, it would not be possible to send data across the internet. 4. Transport layer. The TCP IP transport layer protocols exchange data receipt acknowledgements and retransmit missing packets to ensure that packets arrive in order and without error. End-to-end communication referred to as such. Transmission Control Protocol (TCP) and User Datagram Protocol are transport layer protocols at this level, UDP. TCP. Application can interact with one another using TCP as though they were physically connected by a circuit. TCP transmits data in a way that resembles character by character transmission rather than separate packets. A starting point that establishes the connection, the whole transmission in byte order, and an ending point that closes the connection make up this transmission. UDP. The datagram delivery service is provided by UDP. The other transport layer protocol connections between receiving and sending hosts are not verified by UDP. Applications that transport little amounts of data use UDP rather than TCP because it eliminates the process of establishing and validating connections. 5. Application layer. This layer is analogous to the transport layer of the OSI model. It is responsible for end-to-end communication and error-free delivery of data. It shields the upper layer applications from the complexities of data The three main protocols present in this layer are HTTP and HTTPS. HTTP stands for Hypertext Transfer Protocol. It is used by the World Wide Web to manage communications between the web browser and servers. HTTPS stands for HTTP Secure. It is a combination of HTTP with SSL secure socket layer. It is efficient in cases where the browser needs to fill out forms, sign in, authenticate, carry out bank transactions. SSH. SSH stands for Secure Shell. It is a terminal emulations software similar to Telnet. The reason SSH is preferred is because of its ability to maintain the encrypted connections. It sets up a secure session over TCP IP connection. NTP. NTP stands for Network Time Protocol. It is used to synchronize the clocks on our computer to one standard time source. It is very useful in situations like bank transactions. Assume the following situation without the presence of NTP. Suppose you carry out a transaction where your computer reads the time at 2:30 p.m. while the server records it at 2:28 p.m. The server can crash very badly if it's out of sync. The host-to-host layer is a layer in the OSI Open System Interconnection model that is responsible for providing communication between hosts, computer or other devices on a network. It is also known as the transport layer. Some common use cases for the host-to-host layer include reliable data transfer. The host-to-host layer includes ensure that data is transferred reliably between hosts by using techniques like error correction and flow control. For example, if a packet of data is lost during transmission, the host-to-host layer can request that the packet can be transmitted to ensure that all the data is received correctly. Segmentation and reassembly. The host-to-host layer is responsible for breaking up large blocks of data into smaller segments that can be transmitted over the network and then reassembling the data at the destination. This allows data to be transmitted more efficiently and helps to avoid overloading the network. Multiplexing and demultiplexing. The host-to-host layer is responsible for multiplexing data from multiple sources onto a single network connection and then demultiplexing the data at the destination. This allows multiple devices to share the same network connection and helps to improve the utilizing of the network. End-to-end communication. The host-to-host layer provides a connection-oriented services that allows hosts to communicate with each other end-to-end without the need for intermediate devices to be involved in the communication. Example: consider a network with two hosts A and B. Host A wants to send a file to host B. The host-to-host layer in host A will break the file into smaller segments and error correction and flow control information and then transmit the segments over the network to host B. The host-to-host layer in host B will receive the segments, check for errors, and reassemble the file. Once the file has been transferred successfully, the host-to-host layer in the host B will acknowledge receipt of the file to host A. In this example, the host-to-host layer is responsible for providing a reliable connection between host A and host B, breaking the file into smaller segments and reassembling the segments at the destination. It is also responsible for multiplexing and demultiplexing the data and providing end-to-end communication between the hosts. Other common internet protocols. TCP IP model covers many internet protocols. The main rule of these internet protocols is how the data is validated and sent over the internet. Some common internet protocols include HTTP, Hypertext Transfer Protocol. HTTP takes care of web browsers and website. FTP, File Transfer Protocol. FTP takes care how the file is to be sent over the internet. SMTP, Simple Mail Transfer Protocol. SMTP is used to send and receive data. Difference between TCP IP and OSI model. TCP refers to Transmission Control Protocol. OSI refers to Open System Interconnection. TCP IP uses both the session and presentation layer in the application layer itself. OSI uses different session and presentation layer. TCP IP follows connectionless a horizontal approach. OSI follows a vertical approach. The transport layer in TCP IP doesn't provide assurance delivery of packets. In the OSI model, the transport layer provides assurance delivery of packets. Protocols cannot be replaced easily in TCP IP model. While in the OSI model, protocols are better covered and are easy to replace with the technology change. TCP IP model network layer only provide connectionless IP services, and transport layer TCP provides connections. Connectionless and connection-oriented services are provided by the network layer in the OSI model.